Okay guys, today we're going to be looking at complex numbers, all right? And what we've been working on up until now is we've been working on vectors, and we've learned that with a vector you can have component form, which is like you go over I and up J, or we've learned about polar form, and with polar form you have a what and a what?
A magnitude and a direction.
A magnitude and a direction. It's like it's this long pointed in this direction, all right? So you know mechanically how to do that. You can go from component to polar, or you can go from polar to component. And really it's pretty simple trigonometry. It's just SOHCAHTOA, and you can usually kind of work those things out, so it's not something that you have to memorize. But now that you know how to do it, the thing to see is that you can apply it and you can use it for complex numbers. Okay, so let's say that we have 1, 2, 3, 4, 1, 2, 3, and we had this, and if we said this is the real axis and this is the imaginary axis. Now this I is different than the other I, right? The other I was a vector. It was a unit vector that was in a direction along the x-axis. Okay, so this is the x-axis and that is the vector I. That's a vector I, right?
Yes, sir.
That's completely different than the number I, which is the what number? The imaginary number. And that's what we're going to be talking about. So what you could think of is you could call this imaginary number 3, or it would be,
4.
yes, thank you, 4 plus I3, right? So that is an imaginary number, 4 plus I3, where this is the real part. We go over 4, and then we go up 3 along the I-axis. So this kind of looks a lot like a what? A vector, right? We can just draw a vector. And if I have a vector 4 plus 3I, that's almost like it's in component form, right? But what you could imagine is you could also put it in polar form. And to do that, I would need what?
A magnitude.
A magnitude and
a direction.
A direction. Okay. So what is the magnitude of that vector if you were just going to guess? And so let's say, let's just call it A plus IB instead of 4 and 3, just to make it more specifically. So I have this complex number A plus IB. What would the magnitude? Let's call this. Let's call this C for complex. What would the magnitude of that be?
So would it be like A squared plus IB squared?
Well, not I, because I is telling you more like a direction.
Okay, so it'd be B squared. The
And
square root of that.
Yeah, square root.
Sorry.
Okay. So it would be A squared plus B squared, the square root of that. And just remember, I is telling you the direction.
Okay.
B is the magnitude.
Yes.
Okay, so that's the only little thing to remember. So now, let's say that I want to find the magnitude of the complex number minus 2 plus I5. And this absolute value looking thing, that means magnitude, right? That means magnitude. So how would I do that? Square root of?
Negative 2 squared plus 5 squared.
5 squared. That's 4 and 25. That's equal to the square root of 29. Okay, so that is how long it is. That is the magnitude. Okay, so let's kind of think about it in terms of now that it could be in like the component form, or it could be in the polar form. So let's just take that vector. We're going to say that this is the vector, or this is the complex number A plus IB, and so this is the real axis. This is the imaginary axis, and I have A plus IB. Okay, and so we could say that this complex number Z, a lot of times Z is the variable that you use for a complex number. Z is equal to A plus BI. All right. Now,
is it BI or IB?
actually, IB is a better way to write it. Okay, because putting that I out front kind of reminds you that it's the imaginary number, it's not the vector I, and it's not a variable I. Okay, so let's think. Let's make a triangle, and let's call this theta, and then let's call this like C, like this side is C, and it's at an angle of theta. So what we want to do is we want to go to polar form. Okay, and with this, Z is equal, or I'm sorry, let me correct this. Let's call this R, right? Like a radius, like you think of a unit circle, this is R. Well, Z is equal to R times cosine theta plus R I sine theta. Okay, so if I have a Z, if I have an R at an angle, and I want to go from polar form to trig form, this is what I do. So where do I start? Z is equal to some radius at some angle theta, right? Radius at theta, that's polar form. Now I want to go to trigonometric form. What do? Z is equal to R cosine theta. What up here is this R cosine theta? That's like, how would you describe that in words, this part of it?
So it'd be like the radius times the
Cosine of
cosine
theta, right?
of
But where
theta.
does that put us on this picture? It's this, right?
Oh, yes.
Okay. It's that. That is R cosine theta. And then what is this?
That's
That's
our
our
sine
sine
theta.
theta.
Yeah, R sine theta. And since it's on the imaginary axis, I put an I out there. How
Oh,
big?
so the I really doesn't. There's no. You don't actually put the I in it.
Well, you do here.
Okay.
Okay, because now I have a complex number has a what part and a what part?
Real and imaginary.
Real and imaginary. This is the real part, this, and this is the what part,
Imaginary.
which is
So
up here.
can we? You know how you wrote it over here, I R sign. Does it matter when we're like? Because on the equation you have R I sine of theta.
Well, okay, so what I would say is, if you drew it like this, how long is this? It's R sine theta, and this would be like B is equal to R sine theta, and then when you write it like this, then that I comes in, right? So you just got to kind of keep track of it, okay? So what is, let's say that we start here. Let's say I say Z is equal to R cosine theta plus I plus R, this is Ri sine of theta, right? If we have that, what is R going to be equal to if we look at this picture? If we think of this, let's say we start here. We start here. So where are we starting this time? We're going to start in trig form. And in trig form, let's just say I have A plus IB. Okay? So what is R going to be equal to if I'm given a complex number like this?
It would be
Equal to B, correct?
no. It'd be R would be equal to
This is R.
yes.
And I have what? This is A, and this is
So then you'd
B.
have R cosine.
Let's use A
theta.
and B, right? Because
Oh.
I'm given A and B.
Okay, so then you have A plus
How about the square root of...
A squared plus B squared.
Okay. So if I'm given 3 plus I4, 3 plus I4, the square root of the first number plus the square root of the second number gives me R. Okay? And this, I'm getting into polar form. Okay? Now, how can I get the angle? The angle is going to be equal to, well, you could do cosine inverse, right? You could do tangent inverse, but let's do cosine, right? Cosine inverse of cosine SOHCAHTOA adjacent over hypotenuse of A over R. Do I know A?
Yes.
Yeah, you're given that. Do I know R? I just figured it out. Okay, so this is polar form.
Hold on. So we went from trig form to polar form.
Yeah, and now we're going from trig form here. Do you see this? This is A and this is BI?
Yes.
Okay, so R is the square root of A squared plus B squared, which is R squared cosine squared plus R squared sine squared, but it's really, you can just use the two numbers that they gave you. And so what I end up with is I end up with some R at some angle theta, and that R is the square root of A squared plus B squared, and that angle is cosine inverse of A over R. So I have A and I have B, and look at this. I can put it in polar form. Does that make sense?
Yes, sir.
Okay, are we doing good there?
Yes, sir.
Okay, so let's work a problem. So I'm going to give you z is equal to minus 2 on the square root of 3i. So minus 2 minus I, 2 on the square root of 3. I'm starting in what? Kind of like trig form or component form, right? And so now I want to go to
Polar.
polar. What is the first thing that I should get? I should find what for? What do I want? I want to go to some r at an angle of theta. What should I do first?
You should find R.
R. R is equal to the square root of what?
A squared plus B squared.
And what's A?
Negative 2
Negative 2 squared.
plus 2 onto the square root of 3 squared.
2 on the square root of 3 squared. Right, it's the part multiplied by I. Don't put I in here, right?
So it would be negative 2 onto the square
Okay,
root
yeah.
of 3.
Negative 2 on the square root of 3, and then that squared, the negative is going to go away. So this is 4, plus 2 squared is 4, square root of 3, that's 12, right? 2 on the square root of 3 squared is 12, and therefore r is equal to the square root of 16. Therefore r is equal to what?
4.
4. Is that good? Okay. Now I know that it's 4 at some angle. How do I figure the angle?
Angle theta theta equals cosine inverse of A over R.
And what's A?
A is negative 2
Over
4.
4. Okay. And what that is equal to, you have to think that this is in what quadrant? It's down here. Right, or let's see. So, do you see this is the one that we're looking for either here or I think it's this one because it's
Okay,
negative
go to
both directions. Right. So what does your calculator say?
120.
120. Okay. That's the what answer?
Polar.
Yes.
That is the calculator answer.
Oh,
Okay.
yes.
Now you remember how we've done 6 months of trigonometry? Does the calculator always give you the right answer? No. So it is telling me that it is this one, which is 120. But what is wrong with 120?
That's not a negative.
Yeah, right, there's two solutions. There's this solution and there's this solution. And in this case, which one do I need?
But that other.
This solution. So how can I get that solution? How far am I from 180?
60.
Then how far do I need to go past 180?
1.
Do you see that this these are symmetric about
Oh,
180?
yes. Okay.
Okay.
Oh, okay.
So that'd be 1660.
Yeah, so this would be 60, and if that's 60, this is 60, and this 60 is how far? It's 60 past 180. And so the real angle is equal to 240, okay?
Okay, I'm confused. How did you? I missed how you figured out that it needed to be in the third quadrant.
Where is
Because
Z?
you need -2,
Negative 2,
Okay.
negative 2 on the square root of 3.
Okay, that makes sense.
But you got to stop and look at it, right?
Yes, sir.
And you're going to get in a hurry on your homework, and you're going to give the which answer?
The wrong.
The calculator answer. So rather than using your calculator, would it be better to use the unit circle, because you could see this and look at it on the unit circle? And so the right answer is 4 at an angle of 240. Okay. Now, the difference between 240, which is this point, and 120, which is this point, is that just a small little nitpick thing? Or is it like a really big deal?
It's a big deal.
Yeah, if you're firing a missile and you're trying to fire it at North Korea and you hit Japan, is that a good thing or a bad thing?
That's a bad thing.
So you see, this is not just nitpicking. You see how you've got to, do you see why we had to work so hard to understand the trigonometry? Because if you just go in using your calculator, you're going to get wrong answers. Okay, you're going to get wrong answers. So that's why you've got to do these things. Okay, so there's two ways to write this now in polar form. You could say 4 at an angle of 240, okay, or you could also write it as 4 cosine of 240 plus I4 sine of 240, right? So Z is equal to, or Z is equal to. Because you see here, I'm seeing both the magnitude and the direction, magnitude and direction, magnitude and direction. This is a shorthand, okay?
Mm-hmm.
But do you see these two are equivalent?
Yes, sir.
Okay. So let's see here. Let's work a couple more problems. Let's go the other way. So let's say I have Z is equal to the square root of 8 at an angle of minus pi over 3. Now I want to go to where I have a Z is equal to A plus IB. So what would be a good thing to draw? The triangle, right? Minus pi over 3 would be like this, right? And then what is the magnitude of the vector?
The square root of 8.
Square root of 8, right? And so what I want is, I need like this side, and I need this side. This side is what, A or B?
That's B.
B, and this is A. So A is equal to what for this triangle?
A is equal to R cosine of theta.
Yeah, R cosine of theta. A is equal to, what is R in this picture?
That is the square root of 8.
Square root of 8 cosine of minus pi over 3. And then B is equal to what? The square root of 8 opposite, that's sine of minus pi over 3. Okay? So now, how is it that a lot of people are going to miss this? They're going to plug it in their calculator and they're going to what?
Get the wrong.
They're going to get the wrong angle, right? Because they're going to be in degrees and not in radians. So I would suggest just reading it off of the unit circle. Can you tell me, so if you look at the unit circle, A is equal to the square root of 8. What is cosine of minus pi over 3?
Minus pi over 3.
Yeah, the cosine of minus pi over 3 is what? Come on, where's your unit circle?
It would be 1/2.
The cosine?
Yes.
Cosine? It's minus the square root of 3 over 2. Or I'm going crazy.
I thought cosine.
Sine is y, cosine's the first one, x.
Okay.
Did I do it wrong?
Well, I just have.
Okay, let's look at it. Okay, so where is minus?
It would be here.
Okay, so that's minus 5 pi over 3. Sine
Yes.
is y,
Sine.
1/2. You're right. I was crazy. Okay, so this is 1/2. Okay, and so what is the square root of 8? That's 2 on the square root of 2 divided by 2. A is what?
A is 2 in the square root.
A is the square root of 2, right?
Yes, sir.
B is what? Square root of 8 sine, which is the second one, y of minus pi over 3, which is?
Which is the square root of 8 times negative the square root of 3 over 2.
Okay. It's the square root of 8. And again, this is 2 on the square root of 2 times minus the square root of 3 over 2. And so that's equal to what? Minus the square root of 6. So what is the answer? Minus the square root of 6 plus I, the square root of 2. Does that make sense?
Yes, sir.
Do you see why you want to use the? Unit circle? Makes it a whole lot easier. All right. Now, this is some functions that you can do once you're in polar form. Okay.
So they. Wait. Okay, I have a question.
Uh-huh.
You have A equals. Is that not their up there? Your answer. Should it not be the square root of 2?
Did I write it backwards?
I think so.
Uh,
Because we got as A equals the square root of 2. Because remember.
okay. Thank you. I wrote it backwards. I was backwards 2 times on that problem, wasn't I? So it's the square root of 2 plus I, the square root of 6. Thank you.
Square root of negative square root of 6.
So it'd be minus.
Did I get it right?
Yes.
Okay. I'm sorry. I got those things reversed and then I reversed them again. Okay. So, polar, I have z at an angle of theta. And component, I have a plus ib. If I have let's say I have z1 is equal to a1 plus ib1, and I have z2 is equal to a2 plus ib2. Is it easy or hard to do z1 plus z2? Is this easy or hard?
Easy.
It's easy. How do I do it? The real part is what?
Sorry. So it'd be A1 plus A2.
A1 plus A2 is the real part, plus the imaginary part is what, Catherine?
B1 plus B2.
I'm missing. B1 plus B2.
Okay. Adding vectors in component form is very easy. You cannot add vectors in polar form. If you're given z1 at an angle of theta 1 and z2 at an angle of theta 2, if you want to add those two, what do you have to do?
Go to component form.
You have to go to component form, okay, and then you have to add them,
And then go back
and then you have to go back to polar, right?
Yes, sir.
So adding, you've got to do in component form. But guess what is real easy? It's easy to multiply in polar. Z1 times Z2. Okay, if I multiply these two together, All right, do you know what you're going to get? It's going to be equal to R1 times R2, the magnitude of Z1 times the magnitude of Z2, all right? And the angle is, be careful, you add the angles. So how do you multiply in polar form? You got to do two things.
You have to find R
Uh-huh.
first. And then you
Well, if you're given it in polar form, you have the R, right?
yes.
Okay. So it's just the radius of the first one times the radius of the second one, and what do you do with the angles?
You add them together.
Okay, let's.
Hold on, can I finish copying this, you guys?
So, what if I wanted Z1 over Z2? How would you guess that you would divide them? What would you do with the radiuses?
It would be Z1 over Z. I mean R1 over R2.
R1 over R2. If you were going to guess, what would you do with the angles?
Subtract.
Yeah. Theta 1 minus theta 2. Okay. Multiplying in polar is easy. Multiplying in component, you need to go to polar. Multiplying and dividing, you want to use what?
Polar.
And then adding and subtracting, you want to use what?
Compound.
Component. Okay, does that make sense?
Yes.
All right, so I think that you can do that. That is pretty easy. All right. Okay, then there's just one more. If you go to a power, like if I have in polar form z raised to the n, z raised to the n power, that's equal to r raised to the n, and then the angle is n times theta. Because it's kind of like you're adding n plus, or theta plus theta plus theta plus theta n times. So z to the n is r to the n at an angle of n theta. All right? Let's look at the homework. We are in chapter 6, section 5, and you're going to do 8 through 10. You're going to do 11 through 18. You're going to do 31 through 36. 46 through 48, and the bonus is 104.